Jai Hind everyone. I am Dr. Sanjay Sharma, Faculty Department of Applied Science and Humanities, Ajay Kumar Garg Engineering College. Student, today in this lecture, I am going to discuss a very important topic related to my unit number, module number 3, and the name of the topic is partial differentiation. Student, before this lecture, we have already discussed what is the ordinary differentiation. Its work in case of only ordinary means single independent and single dependent, you can say process. But here we are going to discuss how we take the partial differentiation of a function which is depending upon the more than one number of variables. So in this slide, student, I'm going to discuss what are the introduction of partial differentiation, then what is basically partial differentiation. Later on, I'm going to discuss the example based on the partial differentiation. Okay. So these are the reference book. You can follow with this book. You can go with B.V. Ramanna, and you can also prefer this topic from the B.S. Grewal as well. Okay. So what is basically differentiation of a function? So let fx be any function, right? Let fx be any function. Okay. So it can be written as like y equals to fx. Then if we take the rate of change of y with respect to x, then basically this is some kind of the limiting position when fx plus h minus fx upon h is divided by the function h. Here h is very small quantity which is simply going to 0. This is called basically the rate of change, and this is also called the derivative of fx when we are having some changes in x as well, correct? So this is called what? The change in dependent variable with respect to its independent variable. So basically the rate of change, the derivative of a function is it a rate of change itself, correct? This is not the differentiation, mean the derivative. Okay. So if we going to explore this topic, then what is its introduction basically, and where we have to use this rate of change. Like if student, we are having y equals to fx is a dependent variable in which x we can take independent, and obviously if we change the values, different values in x, so we get the different values of y. So this is called the rate of change basically. The rate of change also take place in a single dependent and single independent variable, but it also can take changes in case of multi-dependent variable. So there is a big difference, student. Here this function y can only be make change when we are going to take the different values of x, but in case when z is given to us, we can change the value of z by making some or more changes in x and as well as some or more changes in y. So this is the big difference between a single independent and single dependent rate of change or variable, and in case of single dependent and more than one independent variable, it is more rapid function, I must say, because here if we going to make some changes in z, we can change z by making changes in x, or also we can making the change in y as well, right? So okay, so if we are looking for the example, that the area of any rectangle is depend upon the length and its breadth, right? The volume of a solid is depend upon the length, breadth and its height. So these are the, mean to say that when we are talking about the area, it's basically depend upon the length and its breadth as well, right? So these are the independent variable for the area. Similarly, the length, breadth and its height are called the independent variable for its volume as well, right? So basically, student, to make some difference, we have to you can say differentiate or denote the partial differentiation differently, right? Someone can understand that he is doing ordinary differentiation, but student, it's different, right? So basically you already do what thing when y is depending upon x, so you have always calculated that dy by dx is called what? Ordinary differentiation. So just to make the different sense, in case of partial differentiation, we have to denote it differently. So student, when we are having a function which is depending upon more than one variable, then its rate of change can be designed or can be denoted by what? The del z by del x. So it's different with dy by dx, it's called del z by del x. So this derivative will take care of the all changes which we are going to make in x only, right? So we can obviously, as I said earlier, we can make the changes in z by reflecting, by making some changes in x. So this is only showing the rate of change in x. When we are having different values of x, we can take the changes in z, right? Similarly, student, if we operate the same thing with respect to y, so we calculate the rate of change in z by making some changes in y. Simply this is called fx and this is called f of y. So initially when you are looking for del z by del x, you can denote it by fx and fy as well, right? So student, like if we are dealing a function which is having the three variable, like independent variable, it's depend upon x, y and then z. So students, simply as I earlier discussed, we can denote the rate of change in function f with respect to x by fx. Similarly, we can make the changes in y, then it also denoted by fy, and similarly student, we can denote del f by del z by making in changes of z, right? So student, here I am just going to discuss some definite application of this dependency and independent variable. So let's take one example before to proceed on its application. Listen up. If u is a function of x, y, z with the three independent variable, then its partial derivative simply, this time student, I have taken here the three independent variable based function. So we can definitely take the differentiation of any function with respect to single variable, then it is called ordinary. We can take the differentiation for one more variable, like more than one variable, it is called partial derivative. In case of more than two variable, it is still called the partial derivation, but as we have number of unknowns here more than two, so it is simply written as del u by del x. Similarly student, we can find the del u by del y, and simply at the end we can also operate the del u by del z. So basically partial differentiation depend upon the nature of the independent variable, right? Now if u is a function of x, y, z, then del u by del x, del u by del y, del u by del z are called its first order partial derivative, because we have just simply taken their single order differentiation. It is called what? Partial differentiation. Even we can go for the higher differentiation like this. If we are going to calculate the double order derivative of the same function, student, then it can also be mentioned like we have already calculated del u by del x, then simply go with the one more differentiation of your function with respect to x. This time this is showing that double differentiation of the same function u with respect to x. Similarly student, we can also calculate the double derivative, double rate of change of your function u with respect to y, and similarly student, this is same with respect to z as well. These are called what? Single order derivative, because their orders are two exactly, then this is called the second order derivative, right? So student, now if we take some example, and we can go to the final adjunction which I have taken out here. So finally, if u is a function having x, y, z, then its single order derivation is called del f. Del f, its differentiation with respect to y denoted by f of y. Its differentiation with respect to z is called fz. If we are going to take their higher order derivation, then simply one more thing here to note down, that is the rate of change double order differentiation of u with respect to x first then y is always equals to, dear student, first y then x, right? So this is very important concept. Now what is the geometrical interpretation of the function? That is another important fact about the partial differentiation. So what is the geometrical interpretation? If you use a function of two independent variable, please remember I have taken here two independent variable like x and y, then your function can be written as u equals to f of x, y. Then basically its paired value, the paired values of x and y represent the area. When we are dealing with the two variable, student, and we have taken out their partial derivative, then it's basically showing the area, right? Let A representing the xy plane, then student, the paired value of x and y basically representing the area of your function. In the same manner, if we are going to dealing with the more than two variable, like exactly three variable, then their paired value basically will give you the volume of the surface. Whatsoever be the function means surface you have to give in. This is called the geometrical interpretation of this partial differentiation, student, right? Similarly, you can see, and even you can note down in your copy, that the double order differentiation of any function with respect to x is always denoted by r. This is the fixed value, right? These are the fixed notation. Similarly, the differentiation of your function u with respect to y 2 times is called as, and this with respect to x first then y and y first then x is always denoted by t. So these are called RST. You have to remember these two. Okay, now student, after discussing the what is the partial differentiation, where we have to use it, now it's turn to calculate the solved example. We have to cover the solved example. We have to learn how the partial differentiation come to the applicable for the example, right? So I have taken very basic question. In this, I have taken one function f which is having x square plus xy plus y square, and we need to calculate the first derivative of f with respect to x, then first differentiation of y with respect to, of function y with respect to y. So what going to happen? Let's see. So student, first of all, let the function f is given to us. We have to take the partial differentiation of this function f with respect to x only by treating this y function as a constant. So it's very simple to say that del f upon del x become 2x plus y. Similarly, student, x del f upon del x mean I'm taking the product of x here. It is equals to 2x square plus yx, right? Similarly, proceeding in the same manner, we can have the values of y del f upon del y. According to the question, we have to add first and second. And student, this is my answer. This is the very basic application or very basic question related to partial differentiation. I think there is no such problem to solve such type of question, right? And my final answer is something like that. This is x square plus yx plus x square, mean it can be written as 2 of x square and 2 of xy, then it obviously become 2 of f, right? I have another question for you, like this time now the function is denoted by z. Z is equals to sine inverse x upon y. So it is clear from the question that basically we are dealing with the two unknowns, independent variable, right? So we can go for the partial differentiation. We can make the changes in z whether by making some changes in x. We can also calculate the rate of change by making some changes in of z with respect to y. So student, simply we have to differentiate my question with respect to x. So the differentiation of sine inverse is always minus 1 upon 1 root 1 minus x of square. But student, here instead of x, we are dealing with the x by y. So it is put it already here. And by making the solution of the under root value, we can say that it is equals to 1 upon under root y square minus x square. Similarly, class, we have to proceed the same with respect to y as well. So here I have taken out the product because this is required here, right? So that is the reason we have taken out the product of x, but now this is denoted by equation number 1. Similarly, student, we have to find the rate of change of z with respect to y. Now sine, because it's also having y, its differentiation is going to same. It is minus 1 upon 1 minus x by y square. But in case of y, we have to take x as a constant. So this is the del y by del z by del y. By making the product in del z by del y by y, this is equals to equation number 2. As we have to add both the results, so finally I have added the equation 1 and 2, and luckily my answer become 0, right? So it was the example number 2, student, and it is very simple and it is very important question to understand, because if you want to understand the high order questions, mean the tough questions, you have to basically convert the little one question very carefully. So this question is covered up. We have next question. This is very important question for your university examination as well. Here, student, first time we have to give in a 3 variable based question. My function u is depending upon x, y and z as well. And what I need to calculate, student, I need to calculate the differentiation of u partially with x, then with y, then with z, and even in addition, I need to take the product of sine 2x, sine 2y and sine 2z. Then I have to prove that the answer become 2, right? So students, simply let's denote the question by u, right? Then we have to differentiate my question with respect to x first. Basically, it's treating like x. So student, when we are looking for the differentiation of log x, it is 1 by x. And in place of x, we have to mention tan x plus tan y plus tan z. and the differentiation of tan x must be multiplied over the numerator. It is sec square x, correct? Now, as mentioned in the question, I need to take the product of sine 2x with del u by del x. It is finally 2 tan x upon tan x plus tan y plus tan z. Now, because it is very simple, student, to understand, we can operate the similar way, right? We can have the sine 2y del u by del y. We can have the sine 2z with del u by del z. And finally, if we are going to add them, so we can say this is twice of tan x plus tan y plus tan z divided by the same one. So it can be cancelled over, and finally we got the answer. It was again very important question. Moving further. Yes, this is 2. I have another example, and student, this example is also very important for your learning power, to improve your learning power. What is the question is saying? We have u equals to x square tan inverse y upon x minus y square tan inverse x upon y. Then I need to show that the double derivative rate of change of u, first x then y, equals to x square minus y square upon x square plus y square. It's a very important question, right? So basically, first of all, I have mentioned that it is denoted by u. To calculate the del u by del x or del u by del y, I need to differentiate the question with respect to y first. Okay, so I have taken out the rate of change in my function with respect to y. So entire x become constant now, right? So in case of x square, it must be same, and I need to take the differentiation of tan inverse y by x. It is 1 upon 1 plus x square plus y square into 1 upon x. Similarly, student, I need to take the differentiation of y square, which is 2y. This time my tan inverse x by y remains same. Then I need to take the y square same, and then I need to take the differentiation of x, tan inverse x by y. By making little calculation, we come to know that the first term converted into x cube upon x square plus y square. The third term can be converted into xy square upon x square plus y square, and the 2 tan inverse y by x remains same here, right? Okay, so by making these two calculation, we can say this is x only. So the final answer of del u by del y now reach to x minus 2y tan inverse x upon y. Okay, so now we have to obtain the partial differentiation of this equation number 2 with respect to x, because student, this is only del u by del y. So to convert it into del to u by del xy, we have to obtain one more time differentiation of this question with respect to x. So I'm doing the same. I need to open the differentiation with respect to x. Now x by taking differentiation converted into 1, and now we are also dealing with the 2 variable function. So we are having here 2 different variable, mean one y present here and y also present here. So by using the same concept of differentiation, student, we can have the answer, and this is the same as I mentioned in my question, right? So this, it was my example number 2 and 3. We have the same example, student. Now here u is given to sine inverse x by y, then tan inverse y by x, and we have to show x into del u by del x plus y into del u by del y. I hope this is very simple question, and we have to obtain the similar way. Simply, u is given to you, you have to open the del u by del x, and you have to simplify the differentiation, right? Then you have to take the product of x over here, right? Then you have to obtain the partial differentiation of the function same time, but this time you have to differentiate your function with respect to y. So by making the this simplification of the right hand side, you come to know that the y del u by del z by del y become this one, equation number 2. We have to get the result by adding second and third. It was 0. So student, you can cover up such example. Now I have very important question. Yes, this is very important question, because this question is slightly different. It's based upon the function differentiation. Later on, you have discussed the question where the formulas you can work, you know how to differentiate sine inverse x upon y. But here, student, we have basically a function, right? Look at the question. What is the question? Here u is a function of x plus ay, and another is a function psi x minus ay, right? Then I need to prove that the double differentiation of z with respect to x2 time is equals to del to z by del y square of a square times, right? So it is very obvious that I'm going to take the differentiation of this question with respect to x 2 time, right? So first of all, I need to put up it in equation number 1, no problem. Then I need to take the differentiation with respect to x and with respect to y of both of the equation number 1, correct? So student, here very important thing I'm going to discuss with you. This is a function, right? And I know it is having x, then no doubt we have to open up the differentiation in this function. When I'm looking for the psi, okay, so you can see there x also available. So both the functions securing x as well, right? So we have to differentiate, and as we have learned already, the differentiation of function is always function dash, right? But look at the function. Inside the function, it's a x plus ay type function. So the differentiation of x here would be 1 and the differentiation of ay would be 0. So we have to add 1 plus 0. So it is not showing here, but it is here. It is basically 1 into f dash x plus ay. And my dear friend, we have to obtain the same condition for the second function. Okay, so now this time we have to differentiate psi function. It's converted into psi dash. Obviously, the function of x, the differentiation of x become 1 and the differentiation of ay become 0. So it's remain 1, right? So similarly, student, we have to obtain the rate of change in y now, right? But this time we very careful because here x is a constant with respect to y and we have to differentiate ay this time. So here you can see a different strategy we have to use. We have to taken out the differentiation function differentiation, that is function, right? F dash. The psi differentiation, that is psi dash. But you can see here I have taken out the product of a and here I have taken out the product of minus a. That is just because of the differentiation of ay must be a and the differentiation of minus ay must be minus of a, correct? Now we have equation number 2 and 3. Then obviously to get the solution, we have to differentiate one more time with respect to x and similarly with respect to y as well. So student, with respect to z, first time we have to proceed the same to get the double order derivation, right? It would be definitely equals to the double order differentiation with function f and with respect to phi function, right? For example, now student, we have to calculate the double order differentiation in y. So I'm going to take the differentiation. So one differentiation reached to double differentiation. We will have one more a extra here, so it reached to a square. Similarly, student, we will have minus of a here, so it reached to minus into minus become to plus of a square. This is my equation number 5. So student, finally, you can see if I'm going to take a square as common, and this is very obvious, then the double differentiation of this function with respect to x equals to the a square times the double order differentiation of the same function z with respect to y. Yes, can we have another example? Yes, I have another example with me. It's a very typical question and it is very important question as well. So student, here first time we are going to deal with the 3 independent variable. So what is the question? The question is, we have to give in u is a function of exponential x dot y dot z. Then I need to calculate 3 time differentiation of u with respect to x dot y dot z, and it reached to the answer which is mentioned over the right hand side. It's 1 plus 3xyz plus x square y square z square and into e raised to power xyz. So student, there is a problem. First of all, we have to understand what is the meaning of 3 time differentiation, then x, then y, then z. So basically we have to open this one. I can take, student, del by del x as common. So you have to mention the remaining part. It would be del f by del y, then del f upon del z, right? I can also take now del by del x and then del by del y as common. So what is left? Here we will only have del u by del z. So this is the simplification of this question. So it is very clear with this explanation. Then we have to open up the differentiation of this given function u with respect to z first. Then we have to differentiate the obtained answer with respect to y, and then finally, student, we have to obtain the differentiation of the combined answer with respect to x finally, right? So you can see here, I have to open up the differentiation of the question with respect to x. Then we will have x dot y and exponential function remain exponential by taking differentiation. Now I need to take the differentiation of z with respect to y. So this time I have del u by del z with y. So there is already calculated values of del u by del z. This time I'm going to take the differentiation of this with respect to y. So this is going to, x is a constant, we have to go with y, and here we also having one y, so we need to use the product rule. It's very simple, correct? By taking exponential function as a common, we come to know the value of del 2u by del y del z, right? So the last we have to open up, del y del z is already calculated over here. You can see now the rest part is we have to open up the differentiation with respect to x over equation number 3. It is very obvious here, right? So it's mentioned here, obviously we have to open up the differentiation with respect to x of del 2u by del y del z. It's very easy. We have to put up the values of the calculated from equation number 3 and we have to differentiate it with respect to x, correct? So student, we can take it into two different parts. So this first is same, we have to, the exponential function is same, we have to differentiate this entire term with respect to x. Then dear friend, e raised to power x y z, this time remain what? X square yz plus x remain constant this time, and we have to differentiate exponential function x y z. So its differentiation is going to take the product of yz, right? So finally student, if I want to take the exponential function common from the entire function, so we will have this answer that was already mentioned in the question. So student, it was your very important logic question. So I'm not now going to take the last question based on the partial differentiation for your practice only, and this is highly recognized question for your university examination as well. So what is the question? Basically, we have to give in x to power x dot y to power y dot z to power z. Then I need to show that if it is a constant, then what happens when x, y, z both are equal? Then you have to prove that double order differentiation of z with respect to y as well as with respect to x, and its answer become x log ex to power minus of 1, right? So there is a problem in this question, student. We are not having any dependent variable on the left hand side. There is no independent variable mentioned. So first of all, we have to open up the logarithm on both sides because we have to check which one is the dependent variable and which one is the independent variable. That is the most important part of this question, correct? So now student, as you can see, the del 2 z is present on the numerator side. So it is very obvious that this question having z as a dependent variable and the rest variable like x and y, they are called or they are assumed as independent variable. That was the logic behind this question. So student, as I have mentioned here, we have to treat z as a function of x and y, correct? So I can differentiate now. It's fixed that z is a dependent variable which is depending upon x and y. So I have opened up the differentiation of both sides with respect to x first. So the differentiation of log c converted into 0 class. Now when I'm looking for x log x, it's a product term. We have to take the differentiation by product rule. Then student, you can see this is entire y log y. This is not having x. Okay, so this is a constant term. This is wholly converted into 0. Now open up the differentiation for z log z. It is basically the first term, then the differentiation of the second one, and the second one with the differentiation of the first one. So student, with this concept, the very important term I have calculated, which is del z by del x. It is equals to minus of 1 plus log x divided by 1 plus log z. That's good. Now student, by obtaining the same fundamental, we have to calculate the value of del z by del y, and by using similar property, student, we can have this value like minus of 1 plus log y divided by 1 plus log z. Now what is my question? Basically I need to calculate the values of del 2 z by del x del y. So I need to categorize, I need to solve it. So what is the meaning of it? We can take del by del x as common, so it is simply del z by del y that I have already. There you are. So I have simply put up the values of the del z by del y, and then I have opened up the differentiation of this function with respect to x. Okay, so this is simply equals to this term, correct? Right. So now we can differentiate this log 1 upon 1 plus log z with respect to x. We will have this one. One more thing to remember, we will have del z by del x and we have already calculated this one from the equation number 2, right? We have already calculated. So by putting all the values, what happen? We will have, listen up, we will have when x, y, z both are equal, so we have to replace all z by x, all y by x. So we will have this type of function here, because there are 2 power, there are 3 power, so 1 power is already calculated over. So what happened? This one can be written as student log ex, and finally your answer is calculated. Thank you very much. Jai Hind.